Hey, what's up, YouTube fans? What I wanted to talk about in this video, right, is evolutionary precursors to live birth that are found in the monotremes, the platypus and echidna, right? The monotremes, platypus and echidna, they are the only living mammals that lay eggs, right? All the rest of living mammals give live birth, right? And this is because the earliest mammals, right, actually did lay eggs more like how the monotremes do, right? But only after branching off from the monotremes, uh, the ancestors of all the rest of mammals transitioned to giving live birth, right? Because the monotremes are the most distant of mammals to all the rest of living mammals, right? They were the first group to branch off from all the rest of living mammals, right? Within the mammal group, right? And so they have retained the condition of the earliest mammals where they lay eggs, right? And also they have cloacas, it's called, which is a single multi-purpose hole used for peeing, pooing, and reproducing. So out of the same hole that they lay eggs, they also poo and pee, right? Therian mammals like us, most therian mammals still retain the cloaca during embryonic development, but then further into development for therians, it divides into separate holes, right? Therians is the group that includes all the rest of living mammals aside from platypus and echidna, right? And the platypus and echidna is that they are more like most reptiles and birds in these respects, right? Most reptiles and birds, right? All birds, in fact, they lay eggs, right? And rather than giving live birth, right? And most reptiles and most birds have cloacas, right? And so the monotremes are more like the reptiles and birds in those respects because that is the setup of the earliest amniotes, right, which goes all the way. So amniotes is the group that includes mammals, reptiles, and birds, right, but to the exclusion of amphibians, which is the other group of tetrapods, right. The earliest amniotes, right, had cloacas and laid amniotic eggs, right? And most reptiles and birds have retained that setup, and the monotremes have retained that setup, right? But then after branching off from those other groups, therian mammals, right, which is the group that includes all the rest of living mammals aside from platypus and echidna, therian mammals evolved live birth and placentas, and we evolved. We began having the cloaca divide into separate holes, right? So that it's not all done through a single multi-purpose hole, right? So in any event, right, the monotremes, while they are more like the earliest mammals in this way that they lay eggs rather than giving live birth, they have a number of precursors towards live birth that are not found in most reptiles and birds, right? Precursors meaning something with the trait doesn't have to transition to live birth, right? Depending on, the environmental pressures, etc. Something with these features does not have to transition to live birth, right? The monotremes obviously did not, right? But it makes it easier to transition to giving live birth if you already have these features, right? And yet you don't have to already be giving live birth in order to have these features. They can be advantageous to evolve before live birth is evolved, as demonstrated by some creatures like the monotremes, right? What are some of these features? Platypus and echidna, like all mammals, they have mammary glands, which are fully functional, producing milk, and the babies drink this milk, and it is vital to the survival of their babies, right? The survival of the platypus and echidna babies, their mother's milk is vital to their survival, right? That is not the case in most reptiles and birds, right? Also, platypus and echidna, the monotremes, they retain their eggs in their body before laying them. After fertilization, they retain the eggs in the mother's body for significantly longer than most reptiles and birds, right? And so even though, yes, they lay eggs, right, after fertilization, the mother carries the egg in the body, right, for a longer amount of time before laying it than most reptiles and birds, right? And so, all amniotes, even the reptiles and birds, all amniotes that still reproduce sexually, fertilize internally. There's some groups of amniotes, not any mammals, but some amniotes are exclusively asexual now, right? So there is no fertilization, right? But all amniotes that still fertilize their egg, the egg is fertilized internally, not externally, like we often see. We tend to see external fertilization in amphibians, and in many fish we see external fertilization, right, where the egg fertilizes the sperm fertilizes the egg externally outside of the mother's body, right? And so all amniotes that reproduce sexually, the mother has a fertilized egg in her body for some amount of time before either laying an egg or giving live birth, which, by the way, therian mammals are not the only amniotes that give live birth. All birds lay eggs, but there's some reptiles that have transitioned to giving live birth independently of therian mammals, right? Although most reptiles lay eggs, right? So in any event, all amniotes that reproduce sexually, when they reproduce sexually, the mother has a fertilized egg in her body for some amount of time, right? And for some groups, it's in the mother's body for longer than others, right? Which is a precursor towards eventually not just having it in the mother for a longer amount of time, but in the mother for such a long amount of time that it hatches inside of the mother. And so then that's the earliest form of what can technically be considered live birth, although in that stage, that they still retain many of the features of the egg that we no longer retain, and they're not as specialized towards live birth as we are, right? But that form of live birth is still seen in some groups of animals alive today, right, where the mother retains an egg inside of her body, right, still retaining many of the features of the egg found in creatures that lay eggs, right? So in any event, the monotremes, right, retain the egg in the mother's body after fertilization for a significantly longer amount of time than most reptiles and birds, right? And so that's a few so far. Another way in which the monotremes have evolutionary precursors towards live birth is this only applies to the echidnas, actually. It does not apply to the platypus, of which, so in the case of the platypus, there's just one species of them, though there's 4 echidna species. So this therefore applies to most living monotremes, right, with the exception of the platypus, that the mothers have something very similar to a marsupial's pouch called a pseudopouch, right? So it's not a full-on pouch, right, but it is functionally very similar. It is a fold of skin which like a marsupial's pouch, right, it covers over their mammary glands, right? And it's functionally very similar because so when the echidna mother lays eggs, she puts the eggs into the pseudo pouch, right? And the egg then stays in the pseudo pouch up to the point of when it hatches, right? The egg hatches inside of the pseudo pouch, and then even after that, even after the baby hatches, it still stays in the mother's pseudo pouch for a significant amount of time before leaving it, right? And so that is a precursor towards a more full-on pouch like is seen in the marsupials, right? And this precursor can get started in egg-laying creatures as shown by the echidnas, right? And so the monotremes, right, while they do not have full-on live birth like most mammals, and they don't have placentas, and they still have a cloaca, right, so still more like most reptiles and birds in those ways, right, they also have features, right, that most reptiles and birds do not have, that are precursors towards live birth, right? Mammary glands, retaining the egg in the mother for a longer amount of time after fertilization, and pseudo pouches, right? Yeah, that's all for now. See you guys.